Hello and welcome. In this video, we're going to be looking at some applications of integration, and we'll be watching how to use integration to find the original function from the derivative and to find the area under the graph and some more situations. So let's start by reading the first question. The first question says that we will be giving the derivatives of the functions along with 1 point on that graph of the function, and we are required to find the function. So the derivative given for the first question, dy by dx, is given to us as x cubed plus x squared minus 3, and we are also given a point on the graph which is of coordinates 1 and 5, so x coordinate 1, y is 5. We're asked to find y. Okay, in order to go from differentiation or a derivative to the original function, we need to do integration. So let's start by integrating this dy by dx. So y is going to equal the integration of x cubed plus x squared minus 3 times dx. Okay, so let's start to integrate. So this is going to be equal to add 1 to the power, so x 3 plus 1 is 4 over the new power, plus x cubed over 3 minus 3x, and since this is an indefinite integral, we need to add the constant of integration. Right now we have most of the function, however we don't know what's the value of c, and here where this second given is going to come into play. We know that y is equal to this plus c, so why don't we substitute the 5 into the y and the 1 into each x and see what we will get. So y is 5, and that is equal to x power 4, so 1 power 4 over 4 plus 1 power 3 over 3 minus 3 times 1 plus c. So over here we will have 5 equals 1 over 4 plus 1 over 3 minus 3 plus c, and this will give me 5 equals, okay, adding 1 over 4 to 1 over 3 and then subtracting 3 is going to give me minus 29 over 12 plus c. From here very easily I can find c by adding 29 over 12 to both sides, or moving this to the other side is going to become positive. So 5 plus 29 over 12 is going to give me c, and my c value is going to be 5 plus 29 over 12, which is 89 over 12. So that is my c value. So I can come over here, say that instead of c is going to be plus 89 over 12, and this is how I went from the derivative of the function to finding the original y function. So y is equal to this. Okay, let's take another example. Let's say we are given the dy by dx, or y dash, same thing, as 2x squared plus 2x, and we're given a point on that original function as 2 and 0. So let's find y. So y again is going to be integration of 2x squared plus 2x into dx. That is going to be equal to 2x cubed over 3 plus 2x squared over 2 plus c. So over here, this 2 and this 2 can cancel, and I can substitute now the 2 into the x's and the 0 into the y. So I will have 0, which is y, equal to 2 over 3 multiply x cubed, or 2 cubed, plus these 2 are gone now. I'm only left with x squared, so it's going to be 2 squared plus c. So now 0 equals 2 over 3 times 2 cubed is 2 times 2 times 2, which is 8, plus 2 squared is 4 plus c. So over here 2 times 8 is 16, so this is equal to 16 over 3 plus 4 plus c. So 16 over 3 plus 4, that's going to give me 28 over 3. So 0 equals 28 over 3 plus c, which makes c equal to negative 28 over 3. And from here, I can say that my final y function is going to equal 2 over 3 x cubed plus x squared minus 28 over 3. And this is going to be my answer. Let's take another example. Let's say we are given dy by dx, or y dash, equals to cosine of x, and the point on the original function is given as pi over 6 and 4. Again, we'll find y doing integration of cosine x dx. We know that differentiation of sine is cosine. That makes integration of cosine sine x. So this is going to equal sine of x plus c. And over here, let's substitute our y into 4. So 4 equals this 4. Let's substitute into y equals sine. Instead of x, I'm going to substitute pi over 6 plus c. And if I put sine pi over 6, making sure my calculator is in radians, sine pi over 6 will give me half. So this is going to equal 4 equals 1 over 2 plus c. Subtracting half from both sides is going to be 4 minus half is 3.5, or basically 7 over 2. And that is going to equal to c. So my y now is equal to sine of x plus c, which is 7 over 2. And this here is the answer. Okay, let's take another example. Let's say we are given y dash as integration of x over square root of 10 minus x squared. From our previous video, which talks about integration using trigonometric substitution, you might see this part and notice that this looks like square root of a squared minus x squared. So the proper substitution that we will need to do here is we can do x equals a sine theta and solve using trigonometric substitution. However, there is an easier way. Okay, if you look closely, you will find something. You will find that we have an x squared here, and the derivative of x squared, or if we take this whole thing, the derivative of this whole thing is basically 2x. So it's something multiplying x, and I have an x here. So I know that this can cancel. So from here, I can use u substitution. And by the way, I did a video on u substitution. I'm going to leave a link to it on the top right hand corner. Make sure to check it out. So let's say we put our u as 10 minus x squared. That makes our du by dx equals to differentiation of this expression is differentiation of 10 is 0. Differentiation of minus x squared is minus 2x, because we multiply the power by the coefficient and reduce the power by 1. So over here, this is obviously multiplied by dx. I can get an equation for dx. Dx is going to equal du over negative 2x, or basically negative du over 2x. So let's substitute everything. So this is equal to integration of x square root over square root of 10 minus x squared is now u, and dx is now negative du over 2x. And from here I can see that this x and this x will cancel, and I will have everything in terms of u. So I can rewrite this as integration of, I can take this negative half outside, and I will be left with du over square root of u. And square root of u is the same as u power half. And I can rewrite this in the final form as integration of, I know I can put this u on the top and flip the powers sign. So it's going to be power negative half times du. From here, I can do my integration simply. So this is going to be negative half times the integration of u power negative half. So I need to add 1 to the power. So what's negative half plus 1? That is half. So it's going to be u over u power half. And then I will divide by the new power. I will divide by half, which is the same as multiplying by 2. And I cannot forget my constant of integration. So over here, I can see that this and this will cancel. This is going to equal negative u power half is basically square root of u plus c. So now I'm ready to resubstitute everything in order to make it in terms of x. Okay, so this is going to equal negative square root of 10 minus x squared plus c. Okay, so now I forgot to give you the point. The point is given. The question gave us a point to use, which is the point that we are supposed to use is 1 and 5. Okay, so over here, I know that this is basically y. So y is equal to this. So if I substitute y with 5 and x with 1, I'm going to have 5 equals negative square root of 10 minus 1 squared. So 10 minus 1 squared plus c. So 5 equals negative square root of 10 minus, okay, 1 squared is 1, 10 minus 1 is 9, plus c. What is the square root of 9? We know that this is 3. So 5 equals minus square root of 9 is 3 plus c. And over here, I can remove the c to the other side. And it's going to be 5 plus 3 equals c. So 8 equals c. So my final answer is going to be y equals negative square root of 10 minus x squared plus c, which is 8. So this over here is my final answer. Let's move on to another style of question. Let's try and read this question. This acceleration, velocity, and position comes a lot in integration and differentiation. So it says that a particle moves with a constant acceleration of 5.8 meters per second squared. It starts with an initial velocity of 0.2 meter per second and an initial position of 25. Find the equation of motion of the particle. Equation of motion means the equation of position. So the position of the particle is equal to something in terms of time. So at time t equals 1 second, I will plug 1 over here into t and it will give me the position at 1 second. At time t equals 2 seconds, I will plug 2 into the t and it will give me the position after 2 seconds and so on. So this is called the equation of motion. So basically, we want to find the position equation. Over here, it gave me some help. It told me that integration of acceleration with respect or times dt is velocity. Integration of velocity times dt is position. So if I start from my acceleration integrated with respect to dt, I will get my velocity. And if I integrate it one more time with respect to dt, I will get my position. So let's do that. So acceleration is 5.8 meter per second squared. Velocity is equal to integration of acceleration. So velocity is going to equal integration of acceleration, which is 5.8 dt. So what's integration of 5.8 dt? Super simple. 5.8 t plus c. Okay, so now I will need to find my c. Remember, whenever we reach this point, we need to have an initial point or an initial condition, which we were given over here. Okay, so it says that the initial velocity is 0.2. What do we mean initial? Initial means at the start, right? At the start, so it means that time equals 0. So in other words, it's telling you that at time t equals 0, velocity is equal to 0.2. And I can use this to substitute 0 over here and 0.2 into velocity. So this is going to be 0.2 equals 5.8 times 0 plus c. So this whole thing is 0. So that gives me c as 0.2. And my full velocity vector is now basically 5.8 plus c, which was calculated as 0.2. So this is now the velocity expression or the velocity equation. Now, in order to get to the position equation is equal to integration of the velocity with respect to dt. So instead of velocity, I'm going to put the expression of velocity, which is the same thing, 5.8t plus 0.2 with respect to dt. So integrating that is going to be equal to 5.8t squared over 2 plus 0.2t plus c. Again, to find c, I will need some sort of initial condition. And again, it told me that initially the position is 25. So again, at time equals 0, my position is 25 meters. Okay, this is 0 seconds, 0 seconds. Okay, so my position is 25 equal to, okay, 5.8 divided 2 is 2.9 t squared. Okay, plus 0.2t plus c. So when time is 0, p is 25. So I will change every t with 0. And over here, this t, I'm going to change it with 0. So this term goes away, and I'm left with c equals 25. So my final answer is going to be p equals 2.9 t squared plus 0.2 t plus 25. And now this is called my equation of motion. And this is how to answer this question. Okay, let's take one more example. This question tells me determine the area below function and above the x-axis. So there is some function. So this is function. So there is some function that is given as y equals negative x squared plus 2x plus 3, and it wants us to determine the area below this function and above the x-axis. So it's always good to try and draw or sketch this area. So I know that this is a quadratic, okay, and by the way, I did a full playlist that is everything you need to know about quadratics, and I will leave the link of it on the top right hand corner. Make sure to check it out. Let's draw our grid and let's try to sketch this quadratic. There are three things that I will need to know in order to sketch it. I will need to know any zeros or solutions or any x-intercepts, and I will need to know where is the vertex. So let's start using the x-intercepts. So I will need to equate my y into 0 in order to solve for the x-intercepts. So I can multiply everything by -1. So 0 equals x squared minus 2x minus 3. I can only multiply everything by -1 when I equate it to 0. I cannot magically change this, okay? So from here, I can do factorization, which the video is again in the playlist. I will need 2 factors of 3 that subtract into 2. Why subtract? Because this is minus. And these are super simply 3 and 1. So I will know that my factorized form is going to be x and x. I will have a 3 and I will have a 1. Since again this is minus, the larger factor, which is 3, is going to copy the middle sign. So the middle sign is minus, the larger factor is 3, so the 3 takes the minus, that makes the 1 takes a plus, and this is equal to 0. So from here I can say that my x is equal to 3, this is my first solution, and my x equals to -1. So over here I have x equals -1, and I have over here x equals 3, and these are my solutions. I know that since the coefficient of x squared is minus, so this term over here is minus, I know that it's an open downward parabola, okay? So I know it will look something like this. Okay, let's try and draw it better. Okay, so this is point and that is the other point, or actually, yeah. So this is my parabola shape over here. I can find the vertex easily. The x coordinate of the vertex is the same as minus b over 2a. This is going to equal minus b, so minus 2 over 2 times a, which is minus 1. So this and this will cancel, this and this will cancel. So the x is 1 of the vertex over here. It's always 1. And then I can substitute that 1 into the y in order to find the y. But I don't need this. This is more than enough. The question tells me determine the area below this function and above the x-axis. Which area is this? It's basically this area over here. That's below the curve and above the x-axis. This area, let's say this part, is under the x-axis, so I'm not gonna include it. So I know in order to find the area, I will need to use indefinite integrals. And by the way, I did a full video on definite integrals. I will link it on the top right hand corner. It's super useful. So we will need to integrate. And what are our bounds? Our lower bound is minus 1, because I'm integrating from here up to here. So minus 1 up to 3 of minus x squared plus 2x plus 3 dx. So let's start to integrate. So this is going to equal minus x cubed over 3 plus 2x squared over 2 plus 3x. And since this is a definite integral, I'm not going to include any constant of integration. I'm just going to evaluate on those two values. This 2 and this 2 will cancel. And let's try and solve this. To solve this, I will substitute the upper bound first, and then I will subtract when I substitute the lower bound. So this is going to be minus x is now 3, so 3 power 3 over 3, plus this 2 and 2 went away, so I'm left with x squared, so it is 3 squared plus 3 times 3. So this is when I substituted the upper bound. And then I will subtract when I substitute the lower bound. So this is minus, my x now is minus 1 power 3 over 3 plus x squared, so it's minus 1 squared plus 3 times negative 1. So over here, I can compute this. So this is going to be 3 squared, so it's 9. So this is minus 9 plus 9 plus 9. So this and this will cancel, so I'll have a plus 9. And then minus this, okay, negative 1 power 3 is negative 1 times negative 1 is basically positive 1. So this is 1 over 3 plus minus 1 squared is 1, and then minus 3 over here. So I'll have a 9 minus 1 over 3 plus 1 minus 3 is basically negative 5 over 3. And when I do 9 minus negative 5 over 3, this is going to give me a value of 32 over 3. And this is the answer. Remember, in definite integrals, we always get the answer as a number, unlike over here when we get the answer as an expression, because this is an indefinite integral. I hope this video was helpful. I hope you don't forget to subscribe, like, and comment down below if you have any questions. Hope it was helpful, and have a nice day. Thank you for watching.